Was there any other question in particular anybody wanted to talk about? Yeah. Which one?
Yes.
The 2026 one, the last one? I think that is, but yeah, okay, we'll talk about all of those. So the first thing I want to talk about is one that I got a lot of questions on, which was number 4. It was a little bit of a trick question. You got to know your order of operations. So number 4 said, which is false. And a lot of people were down to 2 answers. Just put them there. But weren't 100% sure. So there was A, which is 9 minus 5, greater than 5 minus 9. B was negative 12 plus 3 is less than 10. C is negative 2 squared is negative 4. And D is negative 2 greater than negative 4 minus. So most people could tell that B and C are not the right answer. So this one is what? 9 less than 4, that's true. This one is also true. Can anyone tell me which one is true out of those two, A or C?
If you think about it, you're doing -1 times 2 to the power of 2. So you're gonna do the exponent first and you get it 4 times -1.
Yeah, so if you say I square the number -2, that is positive 4. But the way this is written, you're not squaring -2, you're squaring 2 and then multiplying by -1. So a little bit of a tricky question because you've got it pounded into your mind multiple times that -2 squared is a positive number. But this one is actually true. So A was the correct answer. This is true, but -2 squared is in fact -4 because it's -1 times 2 squared. And order of operations has you do the exponent first. So if you plug it into your calculator, -2 squared, it will give you -4. So I want to talk about that one because I got a lot of questions about that. And then which one was the tiles? Oh, number 3. So number 3, I believe, was the tile question. So number 3 said someone has a tile room that is 15 feet in length and 10 feet in width. Each tile is 2 square feet, and George has already used 32 tiles. So how many more tiles does he need? So first, let's just figure out the square footage of the area. So it's 15 by 10, so 150 square feet, right? Everyone's good with how big the floor is? All right, so now each tile is 2 square feet, right? So what's going to happen with that? Can anyone tell me? Yeah.
Like tiles, 2 square feet. 550 tiles.
So let's do like a small, or yeah, do you have a quick answer?
This tile is like 2 because each tile is 2 feet, and then you subtract that you want it. You get.
Yeah. So let's do like a small example because this one's harder to draw out. So like if I took, say, instead of 15 by 10, we would do something like, what's a smaller one that's gonna work? Like 4 by 2, right? So we have to be careful with what it's saying. It is saying 2 square feet, which means the area is 2, not that the sides are 2. So that's one thing where you could get a little bit confused. But if we had 4 by 2, So we're saying the tiles will have to be like a rectangle, or maybe they're still square. But like it's the way that it works out, the sides are not like 1 by 1 or 2 by 2 or anything like that. So each thing that they have would be like this, right? 2 square inches or feet, whatever it was. So we'd have 1, 2, 3, 4, for example. So we're gonna take 4 times 2, 8, divide by 2. That gets me that 4. Same principle is gonna apply for the 150. So if you try to do like 2 inch by 2, 2 feet by 2 feet, you'd have 2. But if you paid attention and saw it was 2 feet squared, so the area was 2, you would get that. So we take 150 divided by 2. What's that? So 75 tiles are needed. And then, of course, we've already put down 32. So what do? Subtract. So 75 minus 32, 43. So that was A, if you remember what letters there were. So that's the tile question. Any questions or issues about this one? Nope. All right. So the next one is the base 4 one. So that one, we're trying to do an addition, but instead of being in base 10, which is what we're used to, we're going to do it in base 4. So let's talk about what that is. So this was number 18. You want to do 32 plus 12 in base. So I think what we're used to is doing base 10, right? So that is 10 digits. We're used to doing 10 digits. It's 0, 1, 2, 3, all the way up to 9. And then the second you hit something bigger than 9, you are going to have a 10th place, right? You're going to have a different thing. And then once you get to 99, with that last digit in both places, then you move to the 100th place. Base 4 is going to have 4 digits. So 0, 1, 2, and 3. And I think with how small these numbers are, at least in base 4, it might be easy to just like start listing them out until we get to that 32. And just look at what those numbers are in base 10, do the addition in base 10, and then put it back into base 4. So let's just start counting. So we have these digits. If this is the highest like number my digit can be, what would the next number be? Yeah. 10, right. Just like with our regular 10, base 10 numbers, you get to 9, which is the last one. You move to having 2 numbers instead, and you're going to go 0, 1. And then you're just going to count with each of the digits in that place. So 1, 2, 1, or 1, 1, 1, 2, 1, 3. And then again, you get to the last number that your digits are allowed to use. And so after 13, what would be next? Yeah, I heard people say it. 20 is next. And then 21, 22, 23 like normal. But again, we've hit the limit. We can't do 24. So we would go to 30. And then 31 and 32. And that's all the numbers we're going to need because we only had, that's the biggest number we're adding. We might have to do some more with the sum, of course. But we'll do that later. So now put it into base 10. And there's like a formula to put it in base 10 as well. But I think this is the easiest if you're not used to it. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 32 is 14 in base 10. And then 12, 1, 2, 3, 4, 5, 6, 7. So 12 is 7 in base 10. So to add 32 and 12 in base 4, we're just adding 14 and 7. In base 10, 14 plus 7 is what? 21. So now we're going to go backwards and put it into base 4. So we need to get to 21, we want to get to the 21st one. Right now we have 14. So we go to the next one, which is 33. And then 40. So let me keep track. This is 15, 16, 41, 42, 43. So 17, 18, 19. We go, oh, wait, no, not 40. Sorry. I thought we were basically 5. So what's after 33? 100, right? You can't actually go to 40 because there's no 4, right? So we filled up all of the places we have. So we go 100, 101, 102, 103, 18, 19, 100. So our 21st one is 111. So 32 plus 12 is 111. And do you guys have questions about that one? You will get virtual credit if you could get it into base 10. But you get full credit if you did all of it. All right. Questions, concerns, or are we just talking? What? Yeah, we'll do 20. All right. All right. All right. Then the last one is number 20. Did anyone know the trick for number 20? So number 20 is the one you want the ones digit of a bunch of like 226 to powers. What do you think it is? So how do you find it though? Mhm.
6 plus 6 plus 6 is 18, and then 20 plus 6, the power of 0 is 1.
Mhm.
And so that would add 1 to the. Like,
Yeah. So I'm not sure how many people heard, but the thing you need to notice about number 20 is that when you start like taking things to powers, you're just multiplying, right? And what happens? So let's say we're taking maybe a smaller number, like 12. We know what 12 squared is, right? What's 12 times 12? 144. But let's do that kind of like the long way. I'm not sure how you guys come for how you guys do it anymore. But what is the first thing that we do if we're multiplying it like this way? Yeah. 2 times 2, right? And then we do this plus 0. So what happens is this ones place is always just what the ones place was squared. And that is going to hold for cubed as well. So for number 20, we have 226 of 0. 226 to 1. So all you have to do all you have to do is take the ones places to the powers. So this one, 2026, that would be 1. From here you'll get 6. From here you'll get 36, which has the one place of 6. And from here you'll get 6 to the 5th. The ones place of that is 9. So that's the trick to 20, because you definitely couldn't have taken all of these and actually found them. Yeah.
What?
Oh, just this. You want the ones that. So you want the one digit of that. You'll get partial credit if you got that for you. But yeah, so the biggest thing you wanted to notice is that the ones place, the rest of the numbers don't change that, which makes it a lot easier because I don't even think a calculator could do this and figure out what the actual number is. So you want to find the trick. The bus one? Yeah. So the bus one is a little bit complicated. It's probably more guess and check. All right. So I did have a question about the bus one. So you want to minimize cost for that. And you have different types of vehicles, but you need to get a certain number of seats of each type, right? So you need 550 regular seats, 20 accessible. So there's a formal way to do that. There's also guess and check. So you can say, and you'll get partial credit if you got one that gets enough seats, even if it's not the smallest cost. So you want to think about, for at least the guess and check, you want to think about what's like the maximum number of buses I need versus maximum number of vans, and then start kind of moving between those two, like going half and trying to see what's probably going to give you the list. What? I don't remember off the top of my head. I have, yeah, still look and figure out the exact answer. But as long as you've got stuff that works out, you're fine. But I'll do it in a second. What's your question? They're worth slightly more points, yeah. Yeah.
It's in the school plans tomorrow, too.
Yeah.
5 vans, 10 buses.
Yes. So the answer was 5 vans, 10 buses. Like it. Yeah, yeah. So a bus has gonna be regular, accessible, there's a van, and regular, accessible. So if we're going all vans, so we need 550 regular and 20 accessible. So 550 regular, 20 accessible. So if we only took buses, how many buses would we need? Yeah. So you need 20 buses, right? Because you'll get the number of regular seats really fast. So all buses, you do 20 buses.
You say van has 20 accessible to buses.
What about if you did all vans?
And I.
I see need to pay attention.
And you know that. What is going on? Do you ever realize it? You know it? Okay.
So how many vans would you need if you were doing all vans? Yeah.
55.
55. So if you take 55, that would give you the 550 regular seats. So then you can calculate how much this costs. You can figure out which of these cost less. If you figured out at least which of these cost less, that gets you some points. But of course, there's better answers. So if we did 20 buses, each bus is $300, right? So this, the cost is 300 times 20, which is what? So. Right? And then the bands are $100 each. So this is $55,000. So Vans is cheaper. But you'll notice with both of these, you have too many of one of the seats, right? So all of the buses, you have enough accessibility seats, but you have a lot of regular seats, way more than the 550. In fact, I think it's what, double? Right? You have double the amount of seats there. And then here, you have way too many accessibility seats. You have 35 more. So the way that you want to do this is kind of take that into view and start thinking about what's going to be better. So are you going to be able to get the exact number of seats? Is it better to do vans versus buses? And the closer you can get to the actual answer, what was the actual answer at the end?
I believe five vans and 10 buses.
Yeah, so the actual answer, if you want to know, is 5 vans and 10 buses. So you might be able to tell that that might be the right answer with guess and check, because like we said, we have double the amount of seats we need here. And so guess and check is your best way. Closer you get, the better. Yeah. Partial credit, even if you got the wrong answer. So that just getting like this would get you a lot of points. Yeah. What? You want for 1 point?
Water.
Yeah, okay. Yeah. Yeah. I'm going to what? Sure, we're getting them graded tomorrow. Yeah, so you'll know whatever. There is a math way to solve this. We can go through other than guess and check. Let me answer. Do you have a question? You don't know. Do you guys want to learn how to do this problem with math or guess and check? Okay. Because we can go through it. What? The clock's up there. A little bit before 5:45. We're gonna finish up in a minute and give you guys the certificates. But the way you would go about solving this one, a little bit weird, but what you would want to do is figure out variables, everything. So the actual way to solve this one, like I said, guess and check, getting as close as you can is perfectly fine. And kind of getting that. The way you would actually solve this is you come up with different equations by putting variables for the number of buses and the number of vans. And you can actually solve things to minimize it. So you let X equal the number of buses and Y equal the number of vans. And you actually come up with not equations, but what inequalities. So you've definitely seen inequalities before, like less than or something. And you maybe even solve like one variable, so like 2x plus 1 less than or equal to 10. You can probably solve that, right? If you have two variables, you can still kind of solve it, but you get like a whole domain instead of like there, you're going to get like an interval, right? Like it's going to be what you get 2x less than or equal to 9, x less than or equal to 9 halves. So you get the interval negative infinity to 9 halves. It's going to be different for these. but we still can come up with the linear inequalities. So we look at how many seats we need, right? So regular seats, you need more than or equal to, so it's fine to go over, but you need at least 550,
Yes.
right? So look at the number you get from each type. You get 50 from X, which is the number of buses, and you get 10 from Y. That has to be greater than or equal to 550. You want to do the same exact thing with the other one. So the accessibility seats, you can go over the 20, but you want to have at least 20. And so you do the exact same thing, but with different numbers. So you get 1 from X and 2 from Y. That has to be bigger than 20. And so you get these two inequalities. And I think maybe drawing a picture is the best way to kind of figure this out. If you have these. So we want to look at all of the possible X and Y values. So you can put this on a graph, say, and you can graph these inequalities. You basically just graph the line and then shade the side of it that works out. So for example, this one, if we want to graph this, look at the equality, if you change that to an equal, and solve for y, put in slope-intercept form. So 10y is 550 minus 50x. So y is 55 minus 5x. You all know how to graph that, right? And then I'm actually just going to put the greater than or equal to back in it. So we want y values above this line, 55 minus 5x. So 5, 10, 15, 20, 25. 10, 20. So we have a point here. It's decreasing by 5. So when's it going to hit the x-axis? 11, right?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we want our y to be bigger than that. So we would want things up here. But that's only one of them. So we also want to look at this line. So we get 2y greater than or equal to 20 minus x. So y greater than or equal to 10 minus 1/2 x. So this one starts at 10. And then it goes down by 1/2. And so it's going to hit over here at 20, right? And it doesn't have to be the best graph. And you'll notice that those 2 points, so this one here at 20 buses, and you have the 55 vans up there, so X and Y. And so you want things that are above both of these lines. And so then it takes a little bit of thinking. We're trying to minimize cost. And cost, you have whatever it was, 100 for a van. It doesn't really matter way too much for this. But other than the buses have to be significantly more expensive. So you have 300 times the number of buses plus 100 times the number of these. So there's actually only 3 options for what's going to make this big. We already found 2 of the options, which is when your y is 55 and your x is 20. Can anyone guess what would be the third option? Yeah. So yeah, it ends up being when x is 10, specifically that part where they hit each other. And if you think it through about like how cost works, if we go further away from any of these points in any direction, it's gonna get to be a bigger cost. Because think about it here, you have 20 and 0. Move this way, cost is gonna go up. Move up, cost is gonna go up. If you're here, move up, cost will go up. Move to the right, cost will go up. And same thing here. You move that way, cost goes up. You move that way, cost goes up. And you can't move left or down because that would no longer have enough seats. So this is the actual full way to figure out mathematically. And this point here is at 10, 5. And so you have X equals 10. So 10 buses and 5 vans. But guess and check was also a completely valid option for this. So I think getting that you have these options for having none of something and then starting to go somewhere between, you'll notice that buses has double the amount of seats that you need. So you might even start at 10 buses and then have the vans that you would need to fill that out, which would get you the right answer. And then you just check around and you'll see that that is in fact giving you the smallest answer. Okay. I think that's all the time we have because we still need to give out the certificates, right? If there are any other questions, feel free to ask. Otherwise, stay in your seat until you get your certificate at least. Yeah. You'll get like the results at some point. I'm not sure, like the awards ceremony. I don't think it'll be that quick.